Hello everyone, Assalamualaikum and good afternoon for our panel and fellow friends. My name is Rasyidah Binti Ramli and I am currently Master in Chemical Science Nature Product. And today I will present my progress presentation about stability and cytotoxicity activity of silver nanoparticles mediated with flavonoid in Euphorbia milli methanol extract. Okay, this is my introduction. In this study, we use Euphorbia milli plant that also called as crown of thorn or mahkota duri. This is because it had highest flavonoid content from its leaf part. It also had various phytochemical constituents that fortify among medicinal plants. What about silver nanoparticle? We include silver nanoparticle in this research because the production can be in chemical, physical, and biological synthesis. Plant also provide better platform in silver nanoparticle because it is free from toxic chemical and it can act as natural capping agent towards the silver nanoparticle. And both of these had great potential for antivirals and anti-dengue properties. This is my problem statement. In this research, we want to find out whether flavonoids compound on itself can act better stabilizer compared to plant extract, and should silver nanoparticle mediate with flavonoid can act better among antiviral activity. If you can see, this is the possible flavonoid and it will provide possible mechanism. So we want to find out which flavonoid that can act to be a possible mechanism. This is my objective. Okay, firstly, we want to determine possible flavonoid compound in E-millimethanol extract by using gas chromatography, and then we will synthesize and characterize silver nanoparticle using possible flavonoid compound, and we will investigate cytotoxicity activity for the most stable silver nanoparticle mediated with flavonoid. This is my literature review. You can see the taxonomy of E-milli here, and then and also a few researchers that had researched about Euphorbia genus, but only few researchers do for E-milli plants. This is possible flavonoid content that I found in my literature. This is my methodology. Okay, as you can see, in this research, the extraction was undergo by increasing the solvent polarity. These methods are used to sort out the non-polar compound to make it easy to recognize only the polar compound. Okay, after that, the 6 extracts were undergoing total flavonoid content to identify which extract contain most flavonoid in it. The most flavonoid content will undergo gas chromatography to identify the possible flavonoid in the extract. We decide to check 3 compounds and undergo the green synthesis of silver nanoparticle, and 3 synthesis compound was characterized using UV visible, FTIR, and also SEM. The most stable silver nanoparticle that undergo that characterization will undergo cytotoxicity activity to retest the toxicity toward the cells, and the cells that we use in this research was a viro cell. After knowing the best concentration of sample in cytotoxicity activity, it will undergo anti-dengue activity. For anti-dengue activity in this presentation, I did not include it because it is still in progress. This is my result and discussion. For total flavonoid content, if you can see, total flavonoid content in hexane, chloroform, ethyl acetate, acetone, methanol, and distilled water are shown in this table. And also, if you can see, methanol revealed the highest total flavonoid content. This is the GC data from previous study. And from our data, we managed to identify some of the flavonoid and proceed with silver nanoparticles study. The three compounds known as rutin, vitexin, and quercetin. Okay, this is my FTIR analysis. If you can see, this is FTIR for quercetin, rutin, and also vitexin. After undergoing the synthesis of silver nanoparticle, it will produce the FTIR analysis like this. The purified nanoparticles were observed in presence of bands due to OH stretching, CH stretching, CO group, CC and CN stretching, and CH out of plane. This is the UV visible analysis. If you can see, I record the UV visible during day by day, and if you can see here, I shown day 3 until day 30. Quercetin is the highest peak, but in the day 49, rutin is the most stable silver nanoparticle among these three compounds because of the peak is keep increasing day by day until day 49. Okay, this is a scanning electron microscope. This is for quercetin and rutin and also vitexin. For quercetin, the average size was 128.5. Then its shape is spherical and also cubic. But for rutin, the average size is 257. The shape is spherical and round. And then for vitexin, the average size is 186.9 and the shape is spherical. Quercetin had the smallest size of silver nanoparticle, with the average size was 128.5 nanometer. Next is for my cytotoxicity activity. If you can see here, we analyze the cytotoxicity activity by during three days, which is 24 hours, 48 hours, and also 72 hours. And we just analyze for pure rutin and for silver nanoparticle mediate with rutin. Silver nanoparticle mediate with rutin and pure rutin induce cell cytotoxicity in a concentration-dependent manner, as illustrated. The result of cytotoxicity assay show that at concentration 1 lower than 90% cell viability percentage. This is my conclusion for my presentation. If you can see, FTIR, we observe the band due to OH stretching, CH stretching, CO group, and CC and CN stretching. And in UV visible, we find out that rutin is the most stable silver nanoparticle, and in SEM, we revealed that quercetin had the smallest size of silver nanoparticle. And for cytotoxicity, we know that the percentage cell viability was below than 90% for concentration 1000. And also this conclude that decreasing the concentration 500 milligram per microliter, the cell was not affected. Okay, this is my Gantt chart. This is my reference. And that's all from me. Thank you.